What's up guys? So in this video I'm gonna deal with this problem that sort of sometimes might come up about given a number, print the frequency of each digit in that number. So I don't know if this has ever come in ICSE or not, but I think it might, and even if it doesn't, it's generally a sort of interesting problem, and it's useful to know, because if you're planning to do computer science in ISC, then this algorithm is pretty cool, pretty useful. So I'm gonna continue from where I left off. I've just copied and pasted and edited a little bit of code, and I'm doing essentially the same thing I did in the previous video. I'm storing number, making a constructor, I am taking input, but now I'm coming to sort of the interesting part. So this is your input and output. Let me make it a little easier to read. So the numbers 1, 2, 1, 3, 2. So 1 occurs twice, so you print that. 2 occurs twice, you print that, and 3 occurs once, so you print that. So again, I'm going to start off the same way by making a copy of my number. Now I want you to think and try to come up with, pause the video right now and try to come up with what way would you use to count the frequency of each digit. And keep in mind that a number might have many digits that are repeated. The number may be like 1, 2, 3, 4, 5, 6, 7, 8, 9, 0, and that essentially has every single digit repeated once. I mean, it's not repeated, but every single digit occurring once. So think about what the edge cases could be. Think about how the input could make your program work. Think about what's the smallest number, what's the largest number, what are your how many frequencies do you essentially need to calculate. So we want the frequency of each digit in the number. So before I show you my solution, pause the video, try to understand the problem, try to write your own code, and then see what I have to do. So now I'm assuming you paused and you tried to at least write something. Even if you didn't, that's okay, because I'm going to show you what you should do or what you can do. I'm going to use this technique called buckets, and it sounds a little funny, but it's extremely useful. A few of you who might be interested in math might know about something called the pigeonhole principle, and this does in some way derive from the pigeonhole principle, in that the buckets are essentially the holes and the pigeons in this case are sort of like the digits are treated as pigeons. So what you need to realize here is that since there are 10 digits from 0 through 9, 10 digits from 0 to 9, then there can only be 10 frequency values, in the sense that you need a frequency value for each digit. So you could keep 10 variables, frequency 0, frequency 1, frequency 2, up till frequency 9, but that's a little tedious, and we know something that we can use to make an efficient way to do that. So what we're going to use, we're going to use an array. So I'm going to keep an array called int frequency is equal to new int 10. So essentially every position in the array denotes a digit. So frequency of I stores, so frequency of I essentially stores the number of occurrences, frequency of digit I. So this is pretty extremely useful, and I'm going to show you how it works. So what I'm going to do is I'm going to first obviously put my digit extraction code here, and I'm going to get each digit is equal to copy mod 10. So this line of code is going to look a little obscure, and I'll probably do it in a few ways. So you can write this as frequency of digit is equal to frequency of digit plus 1. So what this essentially means is get the frequency already at the current digit, for the current digit, and add 1 to it. So how does this work? And I'll show you how exactly this works. But another way you could write this, and this is how I write it, is frequency of digit plus plus. And this is essentially doing the same thing. People get confused because you're sort of using an array and you're doing plus plus, a postfix operator, so people don't understand exactly what's going on. But these two lines of code are essentially identical. And now I'm just going to do copy by equal to 10, and I'll just comment out this line of code because it looks a little confusing. Same as line above. I'll just write that for clarity. So now how exactly does this code work? So imagine you have 10 buckets, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and we're going to fill up these buckets with, we're going to add 1 to each bucket as soon as we encounter a digit. So say for this number 1, 2, 1, 3, 2, 1, 1, 2, 1, 3, 2. I'm just adding spaces for clarity. So first we extract 2. So what happens is we go to the second position in the array, 0, 1, 2, and we make that 1. Then we extract 3, so we make the third position 1. Then we extract 1, so we make the first position 1. Then we extract 2 again. So now what happens is we come here, and essentially this is for position. So let me make this clear: 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, and everything starts off obviously with a 0 because that's how arrays are made in Java. So this is what it looks like right now. Now we come to 2 again, so this increases by 1, becomes 2, and we come back here to 1, and this again increases. So this is our resulting array. So the frequency of at position 1 is 2, at position 2 is 2, at position 3 is 1, and this is exactly what we wanted. So you can see how the frequency array, this is essentially the frequency array. Let me name that frequency array, and these are the indices. So this essentially stores how many times, if I asked you how many times does 2 occur in a given number, so you can use this, and then just the index of 2, frequency brackets 2, will give you the number of times that 2 occurs in the number. So I'm just going to put this entire thing in comments. So now how do we print this? What we do is we iterate over the entire array for int I is equal to 0, I less than 10. Why less than 10? Because 10 is the last position in the array, and 10 is obviously not included, so it's 9 is the last position since there's 9 digits. So now what we do is we check if, look at the output carefully, we don't want to print the digits that aren't there. So we check if frequency of I is greater than 0. So what are we doing here? We're just checking whether that digit actually occurs. So then what we do is we print I plus, and this is just for semantics, make it look cool. This is essentially all that we do. So first we print the digit, then we print the frequency of that digit. So let's test this code out to see if it has any bugs. But before that I need to write a main function, public static void main string args, and here let me create my object frequency f is equal to new frequency f dot input f dot count frequencies, and I think we're good to go. So let's run this. So let me say 1 2 1 3 2, or was it 1 2 1 2 3, it doesn't matter. So there you have the input exactly how we wanted. So let me try this for a few other cases so you understand what exactly is going on. 1 2 3 4 5 6 7 8 9. So there you see every digit is occurring once, and that's what gets printed. So let me try a number with only a single digit. So here you have 2 occurring 4 times. Let me try a number with all digits unique. So here you have every digit occurring once. Let me add a number with a 0 in the middle just to see that that works too. So here you can see 0 occurs twice and 1 occurs 3 times. So this is essentially how it works. Some people call it bucket, some people call it pigeonhole. There's different variations to this, and if you wanted, if someone asked you, can you give me the frequency of characters in a string, you could modify this. It's not very difficult. Instead of making this sort of 10 element frequency array, you could just make that 26 elements, and that's assuming that your characters are only in one case. If it's 2 cases, take 2 arrays, 26 each, one for capital, one for small, and essentially you're doing the same thing. Remember this, remember how buckets work, and that's pretty much all you need to do to calculate the frequency of, say, digits in a number or characters in a string. And this is, you'll find out that this is extremely useful. So I'm gonna leave you with what I'll say is like a homework problem, and give this a try if you can, and I'll show you the solution in the next video. So the problem is, generate a number n whose each digit d occurs d times. For example, let me give you an example here. Say 1331. Oops, wait, 1333, I'm sorry. So in this case 3 occurs thrice and 1 occurs once. So let me make this a little more interesting, because there can be a lot of numbers that satisfy this property. Generate the smallest 4-digit prime number whose each digit d occurs d times. And if you can't find a small, I just made this program up, or I've seen it before and I'm just using it, and I don't remember what the answer should be. So if you can't find a 4-digit prime number, then maybe look for 5 or 6 or whatever, or maybe even look for 3. So try this out. If you can't do it, then I'll have a solution by the next video. So that's pretty much it for this video. I hope you guys are benefiting from this. Share it with your friends, like, subscribe, whatever, and I'll see you with a solution for this problem in the next video.